Hi everyone. So Statistics 5030, Chapter 1, the first video. So this slide is available on Canvas. So you can see in Canvas to see all slides. But in the first few chapters, I would like to use the R language and R Studio, and I demonstrate on screen. Okay, so what is R? The R is the basically statistical language, so it looks a calculator. So once you start R, so this is the screen of R. So this is R console, so we can type some input, then you can get answer. For example, 1 + 1 is 2. Sometimes another window appears after we implement some code. For example, if I make a histogram of 100 random numbers, then another window appears, and you can see the figure here. So you can save this by file save as something. You can change the shape of the graph, or also you can use some code to save this in a specific format with a specific aspect ratio. Also, another window may explain some functions. For example, what is our norm function? Then if we type help norm, then the explanation appears in another window. And R norm is actually the random numbers which follows normal distribution with mean 0 and standard deviation 1. And we can change this mean and standard deviation if we specify these options. So this is Mac version. So if you use Windows or Linux, it looks slightly different, but basically all functions are the same. Okay, so now we want to discuss basic operations. So we have already done addition, and subtraction is the same. For example, the 3/4 minus 1, the 4/3 minus 1/3 is 1. So if you type this, then this becomes 1. Or you can multiply 8 and 31, then you get the 248. So division is just the slash symbol. So how about square or cube or to the nth power? Then we can use this hat symbol. You can type the shift 6 in usual keyboard. So 2 cube is the 2 hat 3. So this is basically the same as the LaTeX format and some other languages. How about square root of 2? SQRT of 2. So SQRT is a ready-made function to calculate the square root. If you type -2, you get an error. Not really error, but the warning message. The square root of 2 can be calculated by the 2 hat 1/2 or 0.5. You can get the same number. Absolute value of -1.2, that is 1.2. Absolute value of 1.2 is, of course, 1.2. And many other functions are available. For example, the useful function, round function, the round numbers. For example, the 2.98. If we round this number, then this becomes 3. Or a round of 2.12 is 2. If you want to get the several numbers after decimal points, you can type, for example, 2.12345, 2, then this becomes hundredth. So this becomes the 2.12. The similar functions, the floor function and the ceiling function. Floor function round down numbers 8.81, then it returns 8.0, again 8. Round up, then you can use ceiling function. Ceiling of 8.81 is 9. If you specify, you cannot really specify the option here. So ceiling function always makes it into integer. So if you want to get the 8.9, then probably you have to just multiply by 10, then maybe divided by 10, then you can get 8.9. So some other functions, the exponential function, so e to the power 4, for example. So that is exp parenthesis 4. So this is again a function. So log base e of 10. So this is 2.32. So e to the power 2.302585 is exp 2.3. This becomes 10 approximately. If you want to make the base 10, log 10 of 100, this is log of 100 with base 10. So 10 to the power, 10 square is 100, so this is 2. Exponential and log are inverse function each other, so for any number, exponential of log is original number, log of exponential the same. So you can type more complicated formula by combining these. For example, if you want to put exponential of 0.01 minus 1 on numerator and the 0.01 as denominator, then you can calculate this. So this basically approximates the slope of tangent line of y is equal to exponential of x at x is equal to 0. Some numbers are already made. For example, pi is 3.14. So sine of pi over 2, this is 1. So sine of 90 degrees. So if you really want to use the degree, then actually you have to make something. If you want to put 90, then basically we have to transform this into pi. So pi parenthesis 180, you always have to multiply. Cosine tangent works in the same way. You can see the slides. Arcsine, arccosine, arctangent, and hypercosine, hypersine. So those functions are also available that you can see slides. That we don't use those functions often in this statistics class. And how about factorial? Sometimes probability, they use many factorial symbols. So we want to get the, for example, 10 factorial, but this symbol actually doesn't work. So usually the exclamation mark is reserved for not. So actually not factorial. Oh, by the way, this pound is the comment. So after pound is ignored. For example, 1 plus 2 pound plus 3, then plus 3 is read as comment. So R only recognizes 1 plus 2. So this becomes 3. Okay, so how about factorial? The factorial, one way is just use factorial. Factorial of 10 is equal to 3,628,000. Sorry, the 3,628,800. And so this is the 1 times, 2 times, 3 times, 4 times, 5 times, 6 times, up to 10. So another way is gamma function. So gamma of something is actually the 10 minus 1 factorial. So if you type the gamma of 11, this becomes 10 factorial. Product, yeah, so these are the way to calculate it. How about the 6 choose 4? So how many ways that you have to choose 4 out of 6? Then that is 6 factorial divided by 4 factorial times 2 factorial. So you can use factorial function. Factorial 6 divided by factorial of 4 times factorial of 2. So 15. So 6 factorial is what? The 720, and 4 factorial is 24, and 2 factorial is 2. So actually the same, 50. And finally, assignments. So you can assign some letter or the sequence of letters for a specific number. For example, if you want to define x is equal to 2, then you can just you can type the x, the left arrow or the less than sign, and this is hyphen, then 2. Then x is defined as 2. So once you type x, then the R recognize this is x. If you type x squared, then it returns 4. X equals to, so this is the same function. Maybe we change the number. X is equal to 4. Then x becomes 4. So you can use the two symbols, and these have the same meaning. So, okay, so we define y as 3, then x plus y is 7. The 4 plus 3 is 7. And the 2 times x, maybe square plus maybe 3 times x, then this becomes 44. The x squared is 16, and 2 times 16 is 32, and 3 times 4 is 12, so in total 44. Okay, so these are the basic functions in R. See you then.